Hello aspirants, welcome back to SKD's Note. Today we are going to discuss about electrical machines lecture series. So in electrical machines we will be having transformers. In the transformer we are going to study about single phase transformers, three phase transformers and auto transformers. Likewise we have DC machines. In these DC machines we have DC generator and DC motor. Okay, so in AC machines we are going to study about synchronous machine. So in synchronous machines we also contain synchronous generator, that is alternator, and synchronous motor. So again we have a synchronous machine, that is induction generator and induction motor. So here next we have special machines. In that special machines we are going to discuss about PMSM, that is permanent magnet synchronous machine, and BLDC motor, brushless DC motor, servo motor, stepper motor, switched reluctance motor, etc. So considering all these machines, okay, we are going to discuss in detail, okay, with working principle of each machine, construction of each machine, working of the machine, and characteristics of the machine, and application where this machine is utilized in industry or in domestic or in commercial domain. Okay, so without any further delay, let's discuss about transformers. Okay, we'll start with this transformer. So firstly, if you know what is transformer definition or what is transformer, please pause the video and drop your answer as in a comment box. Okay, so let's see definition. What is transformer? Definition of transformer. Okay, we know that, or you might be not knowing, so let me explain this. So transformer is a static device. Okay, what it does, it transfer power or electrical power. Where it will transfer? From one circuit to another circuit without changing its frequency. Okay, this is what definition of transformer. Okay, so I will say transformer is not an electrical machine. You might be asking, sir, why? Let me explain you. So it does not have any rotating parts, so here no energy conversion, that is one form into another form, is not taking place. So that's why this transformer is not considered as an electrical machine. So electrical machine should consist some rotating parts, like example DC generator or motor. Commonly it might be any generator or motor, correct? So if we talk about some features of transformer, okay, what are all the features of transformer? So first we should know that transformer is a constant frequency machine. Then we have transformer is a constant flux machine. Suppose in an examination you might be asking like which of the following is called as constant frequency machine or constant flux machine. So they will be given 4 options and you have to choose one correct answer. If there is answer called transformer for the given question called constant frequency machine, you might be choosing the transformer as answer. Okay, so transformer is also called as constant power machine. Further, if we move on, transformer is an electromagnetic energy conversion device. If internal conversion process is considered, only internal conversion, don't get confused with the one form of energy into another form. Okay, that's why I have mentioned in previous slide. Okay, so however the complete transformer is not an energy conversion device, as it does not change the nature of energy from input to output. It is what it is doing, it is taking some input power and transferring that same input power or same amount of power into another circuit. Okay, and we have third point or fourth point, whatever it may be. So let me write here. So transformer is a coupled circuit. Okay, transformer is a coupled circuit. Why it is called as coupled circuit? Why? Because here two windings are electrically isolated. That means they are not connected electrically but magnetically coupled. Remember this point. So transformer is also called as, transformer is a phase shifting device. Why? It offers a 180-degree displacement between two circuits. Okay, so then we have transformer is a singly excited device. Why? Because only why it is singly excited device? It requires only one external voltage source. Remember this. Why? To energize windings. Then the transformer is also called as negative feedback circuit. Why? It satisfies Lenz's law. Okay. So now, here let me draw a transformer first. Okay. So this is transformer. This primary winding, and this is secondary winding. This is primary and this is secondary. Okay. So here primary side is excited, produces current I1, whereas it gives I2 current when connected to any load. Okay. Induces an EMF E1 in the primary side, whereas E2 in secondary side when the flux is linking with the secondary winding. Okay. So this is called flux. This is called magnetic core. So this is V1 voltage. So here we will get V2 as voltage. Okay. So this is what the transformer looks like. Okay. It is having two windings, primary and secondary winding, which are magnetically coupled but electrically separated or isolated. Okay. So first we should know working principle. Okay. Working principle. So all of you know that the basic working principle of transformer is Faraday's law of electromagnetic induction. Faraday's laws of electromagnetic induction. Okay. So here what is Faraday's law? Let's see. So Faraday's law, whenever there is a space variation or time variation exist between magnetic field and a conductor or set of conductor, what happens? An EMF is induced in a set of conductors. Okay, this is what Faraday's law says. Okay, as we discussed in previous session. Okay, so if we talk about basic requirements to satisfy Faraday's law of electromagnetic induction. Okay, basic requirements to generate EMF with the help of Faraday's law of electromagnetic induction. So according to Faraday's law, what we require? A magnetic field, set of conductors, and at last we want what we want? Relative space variation or time variation between above two. Okay, above 2 means what? Magnetic field and set of conductor. So in order to generate an EMF, we require a magnetic field, set of conductors, and there should be a relative space variation. Okay, forward, back and forth, or time variation between them. Okay, this is what basic requirement. What is the basic requirements? Magnetic field, set of conductor, relative space variation and time variation between above two or between them. What are all those? Magnetic field and set of conductor. So here if relative space variation exists between magnetic field and set of conductors is called as dynamically induced EMF. Okay, example, a DC generator. Okay, if EMF is induced in a set of conductors due to relative time variation with respect to magnetic field it is called as statically induced EMF. Okay, remember this. If there is any relative space variation exists between magnetic field and set of conductor, then it is called as dynamically induced EMF, and example for that is DC generator. If EMF is induced in set of conductors due to relative time variation, it is called as statically induced EMF. You got the difference between relative space variation and time variation. Okay, example for this relative time variation, we have example transformers. Okay, further in details, if we talk about dynamically induced EMF, dynamically induced EMF here magnitude of dynamically induced EMF can be found by flux cut rule. Flux cut rule. This flux cut rule can be found by Fleming's right hand rule, by applying Fleming's right hand rule. Suppose we have this magnetic flux density called B. Okay, whenever a conductor cuts, this magnetic field or magnetic flux density at an angle theta and at a speed or velocity in meter per second, there exists an EMF that is called as dynamically induced EMF. Here, according to flux cut rule, the magnitude of dynamically induced EMF, that is ED, will be B L E V sin theta, where B magnetic flux density in Tesla of steady magnetic field, where LE is the effective length of conductor, V velocity with which conductor is moved. Okay, so next we have how this the direction of dynamically induced EMF. Okay, next we have the direction of dynamically induced EMF can be found by Fleming's right hand rule, that is okay. So here this thumb indicates what it indicates here. The thumb indicates motion of conductor, okay, whereas this index finger indicates direction of flux, middle finger indicates direction of induced EMF. So that's all for today's session. We will continue this lecture series tomorrow. Okay, thanks for watching. Stay tuned for next lecture series on electrical machines. We will continue with the transformers again. Thank you.